Okay, so today we're going to cover a few more concepts relating to functions, and we're going to work on a few exercises. You can find Lab 6. Let me go to the class, actually. Sorry, I was in my networking class. In the Chapter 6 module, so if you scroll down to Chapter 6, you'll be able to find the lab. And that's what we're going to do this week. I'm not going to assign additional work to what Mr. McQueen have you do. So you can work on some of the programming challenges if you have time this weekend. I think some of them are not due until mid-November. So just kind of spread it out so you don't have too much to do near the due date. And then there is another exam that's going to come up that's going to probably be right before Thanksgiving. So I'll remind you next week. We'll talk about it. Okay, so today we're going to work on Unit 6 lab. And you can download the document that I had attached to the assignment page. So we're going to talk about function prototyping. This is a common practice, and it's allowing us to be able to tell the compiler what function you're using, what kind of data you're using with your function. So I just want you to know how to be able to prototype it. Some professors require that you prototype. Programmers say they sometimes would incorporate prototype into the function. So professionally, we should learn what the technique is, and you can use it for your projects in the future or not. But I want to show you how you can do that. So basically in your code, you would specify what function that you're using. It is, when we define a function, we really give it a body, but it's kind of like the header to your function. It tells the compiler what kind of function that you're going to have in the later part of your code as you progress. We're going to also tell the compiler that what kind of data that we want from the function if you're using a returning function, right? Those are typed with the different type of data that you're using with it. And then any kind of numbers or values that you are using inside your function, the things that goes inside the parentheses, you want to include that in your prototype. So this is a way that we can preliminary show the compiler that this is the type of function that we're going to have in the code. Now, this is going to be placed before your main function. So you are going to put all of your prototype function at the top. And then you are going to have the main function to do the function call. And then usually you would have the function definition in the lower part of your code. So we'll take a look at how the placement of that from the example. Now we want to declare the function. So prototyping is a way that we specify the type of function that we're using. And later on in our code, we're going to contain it's going to contain the function definition. So yes, or on Tuesday, you really define your function that has the body, the name of your function, and whether it's returning a certain value, right? So we worked on the definition of your function on Tuesday. Now we're going to add the prototype at the top so that way the compiler would know the functions that we're going to implement. If you're overloading your function, you would also include this at the beginning of your code. So prototyping is a way that we can prepare, right, the function that we're going to be using for our program. The benefit of using prototypes is that it allows you to read the program easier. You can also implement modular function, allows us to do modular design anyway. So if you need to fix your program, you only need to fix maybe one or two functions or the mechanism of your program, not the entire program. It also allows the compiler to dedicate spaces in memory and create what they call the function signature for your program to be executed. You can also create a separate file to be able to have, these are called header files, to be able to have the prototypes incorporated in your functions. So that is part of the modular approach, because ultimately application would have multiple coding files, so that way we can run it as a complete program. So what I did was I took the program that you worked on Tuesday, the exercise 4, and it was an overloading program, overloading function program where we use volume function, and we wanted to calculate different volumes like a cube, right, a rectangular shaped container, and a cylinder. So now what we're going to do is we're going to take that program in the example and we're going to prototype the function at the beginning, so that way you know how that's done. So in the program that we previously did, we have include IOStream, and we use CMath to be able to incorporate the function for exponent, which is the POW or power function, and then using namespace std. So the next section is going to be the prototype. So you usually put the prototypes at the top, okay? So first, you are going to give your function a name. So in this case, we have volume as a function. We saw that on Tuesday. And then any kind of parameter that you're putting in the parentheses, you're going to put that inside the parentheses. So it's kind of like putting your name on top of your paper. It's exactly like that, right? We're just going to place the function name and its parameter inside the parentheses, and we would end that with a semicolon. And then because we're overloading, we're going to specify the function name again and the other dimension for our rectangular sides, or the length, the width, and the height for our box. And then the third time that we're overloading, we're going to specify the function name again, volume. And remember that this is a returning function, so we're going to do a double as a type. And then we want to put in the parameters as what we've done on Tuesday. So whatever that you're doing with the function, you want to tell the compiler that this is what I'm going to be doing. And what that does is it's going to dedicate spaces for the signature of your function in the later part of your code. And then in following the prototype, you are going to have the main function. And inside the main, we're going to declare the variables that we're going to use for the parameter inside our function. So side, length, width, height, and radius. And you saw this on Tuesday. And similar to our Tuesday program, the main difference is that we prototype our function at the top. And we place the function definition after the main function. Okay, so that's the practice. If you're prototyping function, you are going to specify the prototype at the beginning of your program. Then you will have a main function. And then in following, right, we would be able to, so return 0 actually comes before your function definition, right? Because return 0 is after the main call the function. So if you look at the example, after we declare our variable in the main, we display, right? And we prompt the user to enter the side of the cube. Then we calculate the volume by calling the function and passing side. So that way it will calculate the cube dimension, the volume. Then in subsequent, we saw the same thing with the box, where we call the function and then pass the parameter for length, width, and height. And that allows us to calculate the volume for the box and the cylinder. I'm going over the example 1 in our lab, which is the same program that we use for overloading with the volumes, but I'm prototyping in this example. So notice that the prototype is above your main function, okay? And then in the main, you're gonna call the function that you're using. And this one we're overloading, so we're calling the same function, but the parameters are different in each call, okay? Then you're gonna return 0 at the end of main. Now, the function definition is placed after the main function, and this is the practice for C++. So at the end, you're going to define what your function is to do. So for the volume for the cube, I'm going to take the side and raise it to the third power. For the volume for the box, I would return the length, the width, and the height multiplication. So length times width times height. And for the cylinder, I also have a local variable. We're going to talk about this in the later part for pi, and I'm going to return pi times radius square and times the height for the cylinder. So the main difference between this example in the lab compared to your exercise 4 that you've completed on Tuesday is that I prototype my function at the top. And instead of defining the function at the top, I define the function after the main. And this is for readability in development. So let's say that you need to change, right, your parameter or change the function. You can go to the later part of your code and change it and then modify how you want to prototype that function that you change. So that way main is still gonna call, right? So we're gonna fix some part of the program. We can edit it. So it is easier to kind of modularly change your program instead of changing everything in main, or, so the practice is that you define the function at the end. Any question regarding the concept of prototyping function? So in future classes, your professor would expect, right, that you know how to prototype function. When they ask you to write a function, just assume that they expect that, and you would prototype it at the top and then define your function after main. And that's just a thing to remember. Okay, so we're gonna do exercise 1, and we're gonna do a shipping calculator. So in exercise 1, it tells you to refer to the example. We're going to use the scenario that's given for fast shipping. And fast shipping charges $5 per pound for domestic shipment inside the country and $12 per pound for international shipment. We want to write a program, a C++ program, to calculate the shipping cost based on the weight of the shipment that the user would input. And we need to make sure that we prototype the function. And in this case, you're probably just going to need one function. And we want to be able to test the program and provide screenshot for it. So I will demo my version of the program, and you can use it, or you can create your own programs. Let me pull this down a little bit. Let's shrink this and close the ad. So in this program, I simply have include IO stream just for C in and C out. At the top, I also have using namespace std. Now, the main difference that we're going to do with this program is that we are going to put in the prototype. So I have a function called calculate shipping, and it is typed as double. When you see that, you know that I'm returning from my function, right? It is not a void. And then inside my parentheses, my parameters are, I'm going to use the variable called weight. That's what's going to be the user input. So we would have a weight that is recorded later on. And then we want to have another variable for destination, because Shipping, we want to know where that's going to, right? So that's going to be typed as string. So in the destination, it's going to hold the data such as domestic or international, right? And the distinguish is that if it's domestic, it's going to be cheaper in the cost, whereas if it is international, it will be higher in the cost. So we want to use destination to check to see if is it a domestic shipment or is it an international shipment. And then in following the prototype for C++, you want to have a main function. And inside your main, we would declare the variable that we are passing by value. So we would have the weight variable and we would have the destination variable. And don't forget your semicolon for the variable statements. Then I put shipping calculator because that's the app, the intention for the app. And I want to prompt the user. So I have on the next cout, I want to prompt the user to enter the weight in pound. So from that prompt, I would then record the input from the user into the weight variable. And then I also prompt the user to input their destination. Is it domestic or international? So they would need to type in domestic, right? Or international at that point. Any questions so far? Let me see if I can zoom in a little bit here to help. So keep in mind that right after our header file and using namespace std, we have the prototype. So that's going to prepare our compiler on what kind of function that we are using and the data that we're using with that function. So inside my main, I would then have a variable called cost. And this is when I'm going to call the function calculate shipping. And I would pass two parameter, weight and destination, just like what you do here. Notice that in the call, you do not put the data type, okay? When you do the prototype, you put the data type double. But in the call of the function, you don't put the data type. You just put the variable name and separate them by comma if you have multiple parameters. And then I want to display the cost. So I have a cout and I put estimated shipping costs would be and the $sign. And I bring down the cost variable so that way the user would see how much they are going to be spending for the shipment. And then in following, that will be a return 0 because it would complete the call. So the compiler would execute the function, right, from the main. And at the end of main, we want to have the closing curly brace. Hello. Now, in following main, the practice for C++ is that you would define your function subsequent to main, right? You prototype at the top, then you have the main function, return 0 from main, close out main, and then we are going to have the function definition after main. So when it does the call, it's going to take whatever that you put in your function definition, it's going to plug that into the main call. Okay, the function call. Now, in your function definition, you will need to type your variable that you put in your parameter because it would need to dedicate space, right, for the value that it's going to bring in from the input. So in the next part of my program is my function definition. I have calculate shipping as a function name. It is a returning function, so I have it typed as double. Inside the parentheses are my parameter. These are the data that I'm processing with my function. So weight is from the user input and destination is from the user input as well. So I want to double the weight because the shipment could be in large value, and string is where they put in domestic or international for the shipment. And because we begin the body of the function, I want to have a open curly brace. Then I have a local variable called rate. And I want to check and make sure that the rate matches the requirement for the company. So if destination is equal to domestic, then the rate is $5. And you can use 00 if you want. Else, my rate will be $12. And then I have return weight times rate. So if my package is domestic, then, and if it weighs 2 pounds, then it's going to take 2 pounds times $5, which the cost will be $10. But if my package is 2 pounds and if I'm shipping it internationally, it will take 2 pounds and it's going to time it by the rate, which is $12. And that requires the user to pay $24. So at the end, after you return, you just have an ending curly brace, and that would wrap up your function definition. So what the compiler does is it's going to take whatever that you define here. When it does the function call, it's going to place that in. But when you prototype, it already take a section, right, of your memory to be dedicated to the variable, the data that it needs for that function processing. So the takeaway from this is if you are defining a function, make sure that you are typing the function, give it a unique name, right? We talked about that last time. And the data that goes inside for pass by value, the variable, you need to type them, or the container, the parameter needs to be typed. Now, when you do the function call, you don't type your parameter, right? It already knows what type from the definition and the prototype, so you just keep it without the type in the function call. And then at the top, you would have above the main, you would have the same exact, it's the same exact name that you define your function and end it with the semicolon. So it's like putting your name at the top of your paper, and then at the end, right, you would maybe sign or put down who you are on your paper. So what that does is that the compiler, C compiler, it actually checks everything from top to bottom before it builds. And if it sees a prototype, it's going to cut, right, a portion of your memory or your RAM for that particular function. So if you have 20 functions, right, it's going to add that to that range of memory, which is the stack, like we talked about that. So at the end of the function call, it's going to flush that space. Now, why is it better to prototype? It's better because it's going to help you, number one, know exactly what function you're using, especially if you are engineering your software and you have many tasks for your software to execute. It's just one extra line, and the placement of your function definition is after the main. Okay? Any question regarding exercise 1? Some of you probably have learned this before if you learned C++, right? So I want to show the function prototype. So it's exactly like your definition, except for when you do that, you end it with the semicolon for the statement. And then in your definition, you would specify the body on what you want to calculate. Do you need to look at certain part of the program, or we're okay? So you can test the program, enter the weight, and then you're gonna type domestic or international, so it's gonna check for that. If you type domestic, then it's going to branch it to the $5 rate. If you type international, it's gonna branch it to $12 rate. Now, you know that realistically, shipping companies don't just do it like this. They actually require that you put in a zip code, right? So in that case, they would have a way to check, for certain zip codes. So it might be a range of zip code, and then it would have a special rate for those zip codes. So if, let's say that you're shipping from California to another city in California, your rate is lower than if you're shipping from California to a zip code in New York. Because, right, it requires additional transportation for your package to get there. So to flash out this program, if you want to make a full-fledged calculator, you would need to do that. So your conditions would be extended, right? And then you just need to update your rate. But you can still overload your function or use the same function to be able to calculate. And when I wrote the lab, I kind of wanted to, so when I taught 17A years ago, my students, they kind of struggle with this because they have a hard time distinguishing like the function call compared to the function definition and the prototype. So the prototype have the semicolon at the end. You just need that one statement. This is the name of my function and the data that it uses, right? At the top. And then in the definition, you would then have the extended body of your function. And then in the function call, you leave out the type of the data in the parameters. Okay? So we're gonna do another exercise with prototype, exercise 2. So if you're done with 1, you can take a look at 2. Yeah.
Okay, take a look on the top.
So usually when you're preparing for your program, you would either do a flow chart. I don't know if Mr. McQueen had talked to you about that, or a pseudocode. And in my classes, when they pseudocode, they usually, put down all the function that they want to use, and then as they move along in the pseudocode. So pseudocode is like a procedure on how you want to be able to start and end your program, like all the steps that you need to implement. So it will help you kind of do an outline of your program. The same thing with flowchart, but flowchart gives you more of the visual aspect. So normally my students would then put in the function name. So they kind of prototype that inside their pseudocode, and then they would go through and they would then define the function later on. But you would do that in English for pseudocode. So you kind of have to state like what your function is supposed to do. Maybe we'll practice pseudocode later. Right. And I'll have the video up tonight in case you want to go back and check. Okay, any question regarding exercise 1? Did you need to look at any part of it? Beginning? So you can also take a look at the example, which is the exercise 4 that I modified a little bit so you can see. So once you finish with your program, you can test it and then just take a screenshot of it. So now you have attempted the prototype of function in C++. So for number 2, I have asked you to write a C++ program. We're going to prototype the function for this program. I want to make sure that I want to check user password length and to make sure that it's meet 8 characters in length and it has numbers and letters, right? You see this a lot when you log into an app. For those of you who aspire to be a UI designer, that means that you have to program the interface for the application. Whereas if you are software engineer, you have to know how to do both sides, the front and the back. So UI designers or UI developers, they normally deal with like the interface on how the user would interact with the application or the website. Whereas software engineer, a lot of the time they would work with, back end server systems and also the mechanism of the program to be able to execute. So because we all know how a login would look like, so I want to implement this, and it's kind of fun for those of you who want to look into cybersecurity. So now that most app requires you to have 12 characters, not 8 characters, but the minimum requirement for most system, at the very basic is 8 characters. So just a side note, how fast do you think someone can use a tool to guess your 3-character password? Let's say that someone used 123. as a password, which most applications don't allow you to. But let's say that I create a password to log into my Windows system 123. How fast do you think it would take me to crack your password? Seconds? Microseconds? What about 5-character password? How fast do you think that is?
I don't know.
Depending also on your system, right? So if you use a powerful system to crack, because it's tried and true. So basically it plugs in numbers and characters in variations, right? Because that's called brute forcing. Um, so I would plug in AABBCC 112233. Eventually, it's gonna guess it with a match, right? So it depends on how fast your system is, but ideally, it would take less than a few seconds to do that. If you have simple password, if you have dictionary password, 5 or lower character password, less than 3 seconds, even on a slower computer. Like I'm talking about a quad core with minimal RAM. Okay. But if you're using a powerful system, which most attacker do, your password can be very quick. Same thing with your wireless encryption key phrase and those things, right? But that's for another class. So we're gonna do a program to require that the user create an 8-character or use an 8-character or longer password, and it has to be complex. But this one, it doesn't really check upper and lowercase. In C++, if you implement a library, you can use is upper and is lower to check for lowercase, but I just want to show you the very basic. So if you need to do this down the line, you can. Okay? All right. Okay, so for password strength, well, let me pull this down a little bit. Here we go. Because password is string for text, we're going to include IO stream and we're going to include string. Right? Everybody type text in for password, and they can also use numbers. We're going to do using namespace std and following the 2 header files. Next, we're going to prototype the function. And I use a bool for this one because my program is to check if the password is complex and long. So I want to check for true or false. So my function is name is strong password, and you can name it anything you want there that would imply the program purpose. And the data I'm going to use is password as a string. Remember that this is a prototype, so we simply have our function name and it's typed, and then the data that we're using with it. So the variable password and its type. And then end it with the semicolon. In following of the prototype, you need to have the main function. And inside the main, I declare a variable that I am using in the parameter called password. So that will be string password. And my program is a password strength checker. So I put that so that way it display that to the user. And I would prompt the user to enter their password. So I do a cout here and ask the user to enter their password. And their input would then be recorded into the variable password using a cin. Then I'm going to check to see if the password is a strong password. So we would say if, and here is where we call the function, right? Remember, my function is strong password. That's the name. And then I would pass the variable. Remember, when you do a function call, no data type there, okay? You have to wrap it inside. This is a parameter of the function, and the function is being used to check for the condition. So it is inside the parentheses there. And then I would display strong password if it meets the criteria. Otherwise, else, I would then display weak password. Make sure you can say use 8 or more character and a number. Now, some login interface or some app would require that you have long enough password, upper lowercase, right? So we would then advance this app to be meeting more conditions. So we're only going to check to see if it's long enough with 8 or more characters and if it has a number. With that, we would then return 0 for main and close that up. So when you're looking at the web app, if it has different mechanism and different interface, usually in a modular approach, it is separate component. They're called features in the app, and they're written as separate programs, and then they're brought into the main program. So you can have one main program and you can have these separate codes. So I would have a separate code for login, and I would have separate code for bill pay, and I would have separate code for account balance check or statement download. Those components are in separate, but then being used together in a web app environment. Okay. So think of it like this is one feature of your app is the login, and this is what you're writing to check your password. So in my function definition, I have, again, right, it is type bool. I prototype that up here, so it's the same. And the same function name and the parameter or the data that I'm passing for the value. Now, this is a built-in C++ function. So what we want to do is we want to check to see if it has a digit or a number. So we would have bool has a number, and we want to specify that as false at the beginning. So if it doesn't have a number, it's going to loop through the entire string, and it's going to check for the character. Each character it's going to check. So if your password is, 10 characters, then it's going to check from the first character to the 10th character. And then as it goes through each character, it's going to see if it has a digit. So we're going to use is digit for each of the character. If it does, then the password has a number and that becomes true. Then we're going to return the password, and we're going to also check for length. So password has to be greater or equal to 8 characters. And we're using a logical operator here. So these criteria has to be true. It has to be 8 or more character, and it has to have at least one number. You can actually use an STL, and it has all this mechanism like is digit, is upper, is lowercase. So there's library that they created for this. But in this case, for the has number, you force it to use a for loop to check every character for a digit, right? And if there is a digit, then that becomes true. If it is true, then it's going to check for the length with it. Now, this is one approach. You can also use other approach to be able to check every character. So you can solve this problem differently in your code. But ultimately, we still have to have the input from the user inside the main. We need to call the function to check the password from the input inside the main. And for our function definition, we would then build a mechanism for it to check the characters and the length of our password. And that's how you do it. Any question? Another way that you can approach this is that you can, instead of having a bool type of function, you can also create like an int function and then be able to loop it and return the number of characters that the password currently have, build a condition to check if it's greater than 8 or greater or equal to 8. And then, but ultimately, to simplify it, you still have to come back to the true or false condition, right? But yeah, you can do it that way as well. So we can do character counts as a function and then check the number of characters in the current password from the input against 8, right? And then as it checks, we wanted to also see if at least one of the character is a number. So you notice that in this for loop, right? This is a later version of C++ that you can simplify it this way. I mentioned before that for loop has 3 parts, but you ask, well, why is there only 2 parts? But you see here, it says the character in the password. Python is similar to this, but you using the keyword in. So you use a colon here to indicate that the character here is part of this group of characters or string. And then from there, it would check the beginning to the end of the string. And so we would check for the if is true, right? So if at least one character is and has a number, if that's true, then return password and check for the length. But you can also write traditional for loop. Okay, if you missed the top, I will scroll back up a little bit. So now we know how to write a password checker. You know how on Google and some of the online like browsers or online apps, sometimes it gives you recommendation of a complex password, right? So a lot of the times it uses a random generator and it pulls different characters and but it does check against the requirement for the app that you're currently using. So let's say that I need a 12 character, it would then generate random 12 characters and then check against that. Your name? I think you emailed me, didn't you? Okay, all right. Uh-huh. All right, any question regarding exercise 2? You're able to run it successfully? So, like I said, right, this is one way to solve this. You can also look into other ways to write it for practice. Okay, so when we are successfully complete the program, screenshot that so that way if you go back later and you can look, see what you did, you can also save your program. Okay, so if we talk about function, we need to talk about the variables that either belong inside the function or outside of the function, right? What's the difference? And this approach is the concept is the same for many different languages, especially C-based language. So in part B, it talks about local variable. You've seen local variable and you have created local variable in the last exercise and also in the prior exercise. But we want to distinguish the difference between a local variable and a global variable. So when you declare a local variable, it is inside your function. So it would follow your curly brace that you open, right? It's in the body of your function. It can only be used within that block of your function. It's only used locally for that function. So sometimes you only want that variable to be used for that particular function, and then you would have other variables for other functions, right? So those are local variables. After that function is ran, the local variable is destroyed or it gets overwritten or deleted by the system. So when you declare a local variable inside the function, like I said, the compiler is going to dedicate a space for the function and its variable. Okay? So inside the function space, whatever the variables or however many variables you have, it's going to create enough space to accommodate those variables. After the function is called, the system would then delete that space and that variable becomes forgotten or destroyed, okay, with the functions. Okay. All right, so it would be like this, right? You would have a function, for example, called display. A local variable is inside that function, like local var here. And then once that's used, it's gone. Okay? Now, global variables, you need to declare above your function. Okay? It needs to be outside of your function. Usually it's on top, next to your prototype. So if you have global variables, you want to put it on top of your code. And it can be used by any function. So sometimes you want to use that data, that same set of data for multiple tasks. Okay? And so we want to place it above all the functions, and then it would exist throughout the program. So once the program is done, then that space also gets removed for the use, right? Okay, so the example here, you would see that I have a global variable that stores the value 100. And notice that it is at the top, right, above your function, okay? And then you can have a local variable inside your function, but in this case, it's only showing the global. Notice that it is above the void function here, right, above the main. Okay, so you, whatever the variable you want to use, put it at the top. Now the difference, as you can see, I put a table for you here so you can see. The lifetime of the local is only within the function, okay? So once the function is ran, it's gone. But the global variable, it exists throughout the program for other functions to use. Now, I talk about the stack. This is a memory space that is used for the compiler to access data. So the stack is just like memory address range inside your RAM that is used for the function and its variable, its local variable. In the global variable, it actually uses a memory address for a specific thing outside of the stack. It is in a different location. It's kind of like, you know how you put a lawnmower in the garage, right? And when so you take your lawnmower out and you put it on the lawn. Think of it like that's the stack area. And then when you're done with lawn mowing, you put it back into your garage, right? That gets put away. Whereas if you are doing other tasks, you would have a specific location, like, for example, your computer, your laptop is going to be in your room. So when you use it, it's always going to be there, right, on your desk. So it dedicates a space specifically for global variable. And you would use local variable for temporary calculation only. That's just for that task. Whereas if you're using a global variable, that's going to be for the entire program for other tasks. Okay, so the example that you see, I use a program to calculate student enrollment. So I have a global variable that stores 100 for 100 total students. And then inside the function where I add up all the students, I have a local variable, and this is going to be inside the void function, right? So I would do a running sum for this, and I would be able to display the total number of students for the day. And then I have another function to display the total. So it's going to use the global variable data, and I would be able to display that, right? So you might have multiple functions to be able to access global, and then one single function to access the local variable there. And then in the main, I call the function, and then I pass the value. Okay, add 5 more students, and then show the total. So you do see the difference in this, right? Any question regarding local, global? Okay, we're gonna do a banking app. I like banking app because it's easy to kind of understand, right? And you see this for business use or personal. So Daryl's bank checking account has $1,000 balance. That's what he has in his account. He plans to deposit $200 each day. That's maybe to save up or whatever. We're gonna write a program to track the total number of, or the total money that he has in the account using a global variable. So that's and then the daily deposit using a local variable. So your daily deposit is $200, right? And then your balance is going to be a global variable, including the 1,000 plus, right? So it's going to increment. Yes.
200 is local.
Yeah, because each day. And then we are going to use a non-returning function similar to what you see in the example. Okay, so let's take a look. Let me pull this down. Okay, so I have include IO stream at the top. Sorry, let me close the ad. It's a short program actually. I'm not prototyping in this. And then I have using namespace std there. I have a global variable at the top. That will be my account balance. And I started with $1,000 for Daryl's checking. And if you want a prototype, you can. The placement for your function definition is just after main instead of before. I did it for this. Then I have a non-returning function called deposit. And the parameter I'm going to use is amount. So this amount variable is local to my function deposit. And also the daily deposit is amount. So that's like $200, right? You can initialize the $200 here, but it's going to only be executed here. We want to continue it. But anyway, you can do that also. So I basically use two variables to represent the $200 deposit each day. And the daily deposit is a local variable. It is referenced as, I shouldn't say reference, it is amount also. And I'm going to do a running sum because we want to keep incrementing for each day. So account balance is itself plus the daily deposit. And I want to display how much money is deposited. So deposited amount or deposited dollars, and then bring down the daily deposit amount. I have a second function called show balance, similar to your example that you see there. And we are going to display the current balance, and we're going to bring down the account balance value. So if you deposited $200, it's going to take that $200 plus the 1,000 gives you $1,200. But if you deposited $0, then it will still be $1,000. So whatever that would be the deposit amount, it's going to get added and shown in account balance. You can say display balance or show balance, that's up to you. And then lastly, I have the main function, which calls, right, the deposit function and the show balance. And this one I hard code, so I just put in $200 because that's what was given to us in the problem. So you basically put in the value as the parameter here, pass by value. It's going to plug this into the function definition as you use it in the call. So it's gonna execute that with whatever that you defined here by plugging in the $200. And then I have a second function call to display my balance, so show balance, and then return 0. Like I said, right, no prototyping for this because that wasn't a requirement in the exercise, but you can just place the definition after the main and then add the one statement for the prototype. Pretty easy. If you need help or have question, let me know. So can you have one or two function? Well, I wanted to be able to apply the global variable concept, so I'm using multiple functions so you can see that your account balance is carried into the show balance function, right? Um, you can also still have account balance being used, but we have to apply in a way where we would see it being used in other function as well, right? So that's why you have two functions instead of one. You can write this program with one function, but it would defeat the purpose of having a global variable. It would just one function, okay? The whole point of a global variable is that it can be reused in other functions, so that's why we have multiple. If you only have one function, I've seen a lot of students program not even having a function, just everything in main, right? That's just very basic. You want to use technique that shows that you can code in C++, that you understand C++ concept, especially if you're going for an internship or a job. So you don't want a very basic program because anybody can write a basic program. Even AI can write a basic program, right? Or even advanced ones AI can do. So, all right. So test the program and see if it adds the deposit. Now, if you can add more component to this by having the user input the amount of deposit that they want, right? Or you can calculate like the balance after a week or a month or a year if Daryl continues to put in $200 each day, right? Or it could be a business that they deposit their sales amount each day, etc. We typically put in a hard-coded value like this if you're just testing a program. If you want a program to be used with the user, you should prompt them to input a value. That's more realistic. Any question? The problem looks more complex than the actual program. It's shorter than the last one, right? But this one doesn't have prototype. Okay. So my suggestion in the future for other C++ classes, when you look at the problem, ask yourself, right, what kind of variables and function I want to create. Is my variable global or local, right? The local stays within the function, so you define that within and you use it for that function. So if you are reusing data, your data needs to be stored in a global container. It doesn't have to be a variable. We're going to talk about arrays or other things down the line, but that needs to be at the top because the compiler needs to know that it's reusing that storage location that contains the data. And in other languages, you have to use the keyword local or global, right? But C++, if you place it at the top, the compiler would know that it is a global variable, a global container. All right. So no question on exercise 3. Test it, provide screenshot of your program code and output. Pretty easy. We're gonna do the last one, and I will be here. This one's a little longer, but I'll be here after the session end until your class ends in case you need help or have questions. I updated your grades for the things that you submitted. So if you continue to do that, I'll update your grades throughout until we meet again. Okay, so for the next part C, we're going to talk about stub and driver. By definition, a stub is just a placeholder function. It's used to kind of doing a simulation, and you normally use these things for testing purposes, right? Like if you're trying to determine or predict if you are making an assumption, right? Using your program. And so it is used for simulation purposes only. And that means that you don't want to fully implement it yet until you test everything out. So it's like using it to test out what it could be. So you can use it for calling the function that is ready, but the call function that is not, right? So for example, if you create a function called calculate pay, like a payroll, and you also have another function called get hours worked, but this one is not done yet. We still are trying to expand the second helper function. So you simply create a stub that returns some kind of test value. So that means that as a developer or a programmer, you can use a stub to kind of still expand your program, but testing it as you go. In programming or in software development, we call this as an agile approach. Is you kind of test it as you go. You don't want to wait till the end and test it. And if something doesn't work out, then you have to scrap your program and start all over again. And that can take months or years, right? So we want to be able to test some mechanism in our program as we go using a stub. The driver is a test function. This is used to call and test another function. And they go together, a stub and a driver. Okay? So for example, if you finish the first function, calculate pay, but the entire program isn't done, so what you can do is you can use a driver to test the function that you completed, which is calculate pay. So a stub simulate a call function, and that function can be missing. A driver is used to test a call function, and the calling program, the entire program might be missing. So these are like ways for us to test pieces of the program, okay? All right. So here are some example. So this is a payroll program, right? It tells you that in this example, the function get hours is a stub, and we are putting an arbitrary value, which is 40, like 40 hours that's worked by the employee. And we want to calculate how much money they would make, kind of just doing some prediction. And it's going to use the data that you give it to be able to test. So you would use this for temporary purposes. So here's the step function, right? We're going to return 40. So plug in the 40 hours to see how much they would make. And we would take that and apply that to the hourly rate. You can also try it with, so in the main, when we call calculate pay, you can put in if they make $25 an hour and if they work 40 hours, how much that would be. So it's kind of like, you know, making a pre-assumption of your pay, right? The output for pay using the stub and the stub. For the driver, we would then use this to test separately, and our program, again, is not completed, right? So here you have a function, and this is what you're going to be testing. We're still going to take the hourly rate plus times the hours that we worked. So for the driver function inside the main, you can declare the rate is $20.50 and the amount of hours worked is 42. Right? And you'll be able to calculate that out. So the driver itself is simply putting in also arbitrary value, but then you're calling the stub, which is potentially is just a test function. Okay, this might be hard to grasp a little bit, but we're going to put both of them together inside the next exercise. So we're still going to use a banking type of program. We are going to implement stub and driver inside our program. So first, we're going to have a function called deposit, and this one is completed. Okay. Second, we're going to have another function called withdraw, and it's not done yet. We're going to use the stub for the withdraw and the driver to test both. Okay. We're going to have a global variable like the last one that's going to initialize at 2000. We're going to use the deposit function to add $300 into the balance. And we're going to use the withdraw function to subtract $200 from the account balance. And then we're going to use the main to test these functions. So here it is. Okay. So at the top, I have include IO stream and using namespace std. There's no additional header that I need for this particular exercise. I would start with declaring a global variable called account balance call balance for account balance. Just like what you've seen in the last exercise. So it's initialized at $2,000. As the requirement for the exercise, I have a deposit function, and this is a non-returning function. It's for void. And I want to bring, I want to use amount variable as a variable for passing by value. So for the deposit function, I want to display depositing. You don't have to put in here. I just note that so that way I know. And I want to bring down the amount. And for the balance, I want to take the balance itself, which is $2,000. I'm going to add it with the deposit amount. And I want to display the updated balance and bring down the balance variable. So if I deposit $300, it would then take that $300 and add it to the 2,000, so it will be 2,300. Now the next part is your stub. Here's your stub function. I have a withdraw function, and the parameter, its parameter is going to, we're going to use amount variable inside the parentheses there. So for the display, I want to have the distinguish, but the distinguish function for stub. So the stub is the withdraw, and when I call it, it's going to display the amount. So it's going to subtract. Then I have a placeholder function, which is stub, and it's going to show the withdraw. We're going to simulate the withdraw and show the amount. So it's like a way that we can test, right? Sometimes you can see how much money that you withdraw until you are over your balance, right? So this is a way that we can test it. Then for the fake withdrawal, I wanted to take the balance and subtract the amount. So if I withdraw $200, then it's going to take the balance and subtract $200. And it would show the temporary amount after the withdrawal. So here I have a balance, right? Take the balance and subtract the withdrawal amount. And I want to display what would be the balance after the fake withdrawal. Now, the question requires us to use main to do the driver for testing. So after I have the second function, make sure you have the closing curly brace for its body. And then I would begin my main. So in my main, I just displayed that this is a banking system test with the driver program. And I would have the initial balance. I want to display the balance, which is $2,000. We'll continue shortly, so. Then I want to test the deposit function, so I wanted to put in $300 for the deposit as the question asked me to do so. So I would then call the deposit function and then the value passed is 300. So it's gonna test with $300 deposit, and we're gonna test it with the withdrawal. So after that, we're gonna call the withdrawal function and we would pass $200 for the value, and that way we can see what our balance would be. And then after that, we would display the simulated balance. You don't have to put the next C out. That's just separating the other one, but with a bunch of dashes. And then I have the third C out to show the note that withdraw function is a stub function and it's not fully implemented. Just keep in mind that the stub is, in this case, when we do a driver, it's testing a function that's not fully implemented. And then I do a return 0, close out my main, and that wraps up the program. So how is this program useful? Well, you can use it to test portion of your software, but you can also flesh out the program for like research purposes or prediction purposes, right? Where we don't know the actual data, what the actual value could be. It could be more or less than what we would see in this case, deposited or withdraw. So you can test it to see what the result could be, right? And you can use this in many different applications. So we can say, oh, we wanted to do like a bank qualifying app where we would say that what could the user, how much money the loan would be if, right? If the user could make the salary or they could have like a certain amount of credits, etc. So you can test out some application that way. So Stub and Driver tends to be more for like software development where we don't have the complete program or the complete function, we can test it. So after the return 0, don't forget your closing brace for the main function, and that gives us the entire program. After this, I'll take attendance and then you can stay to work on some of the tasks that you need to work on or not. Have a wonderful Halloween. Be careful. Okay. And I'll see you next week. Don't forget to answer the last question of your exercise, right? What did you learn about prototype function. We learned how to write prototype statement, and that's at the top of the program, above the main, and then defining the function definition or declare the function definition at the bottom of your code after main. We also learn how to use global and local variable and the difference between them. And then we last practice on the last exercise here is your stub and driver. We can use the stub to as a placeholder function, and we can use the driver to test incomplete function. And you can tell me how you can use that in your future projects. Some of you might be working on like scientific projects or even applications that you will be building. Okay, do you need any help or have questions? I'll give you some time to work on this. Fine. Okay. Okay, any questions regarding this program? Did you need to see the top one more time or? Yeah. And I'll do attendance real quick too, so give me a few seconds. Okay. Okay, are we okay? Let me stop recording real quick. I'll put the